Hello everyone. Today we start the first chapter of the second part, that is complex number. जैसे कि मैंने बताया था आपको, ये चैप्टर्स हम वीडियो लेक्चर से कंप्लीट करेंगे. ओके, सी द इंट्रोडक्शन पार्ट of the chapter. So consider x square plus 1 equals to 0. This is an equation which has no solution in the set of real numbers because there is no real number whose square is -1, right? So we need to extend the real numbers to a larger set. So we introduce a symbol I. It is a Greek letter and read as iota, such that I is equals to root -1 and I square equals to -1. I is called as an imaginary number or imaginary unit, right? So now we define the complex number. This is actually the textbook. It's a page of your textbook. Okay, so open the textbook to understand things. See what is imaginary number. A number of the form bi where b belongs to r, b not equals to 0 and I is equals to root -1, that is called as an imaginary number. These are the examples. I satisfy the following properties, that is I into 0 is 0. If a belongs to r, then root of minus a square is equals to root of I square, a square, that is plus minus ia, right? If ab belongs to r, ai equals to bi, then a equals to b. Now see how complex number is defined. A real number of the form a plus ib where ab belongs to r and I equals to I is -1 with I square equals to -1 because I is root -1. This is called a complex number and is usually denoted by z. Complex number is usually denoted by z. Z is equals to a plus ib where a is the imaginary, a is the real part and ib is the imaginary part, right? See, re means real z or r means iz means imaginary z. Re or rz is real part of the z, means real part of the complex number, and imz or iz means imaginary part of the complex number. Then see the algebra of complex number. What is that? The two complex number are z1 equals to a plus ib and z2 equals to c plus id are said to be equal if their corresponding real and imaginary parts are equal. See the example, a plus ib equals to c plus id if a equals to c and b equals to d, right? So using this equality we can solve the example, right? See this, if x plus y equals to 4 plus 3i, then x equals to 4 and y equals to 3. If 7a plus I into thrice a minus b equals to 21 minus thrice I, then find the value of a and b. So equating the real and imaginary parts, we can find the value of a and b. See here, 7a plus 3a minus b I is equals to 21 minus 3i. Equating the complex numbers, 7a equals to 21 and therefore a equals to 21 by 7, that is 3, and thrice a minus b equals to -3. So 3 a is 3, 3 into 3, 9 plus 3, that is 12. Value of b is 12, right? So this is the first algebra. See what is next. This is conjugate of complex number. What about conjugate of complex number? Conjugate is indicated by z bar. Okay, and z bar equals to, if z is a plus ib, that is complex number, then z bar, that is conjugate of complex number, is what? A minus ib, right? Then properties of conjugate, see here, these are three properties of the conjugate. After this addition of the complex number, it is the next algebra. That is, if z1 equals to a plus ib, z2 equals to c plus id, then z1 plus z2 is this. How we add these two? Real parts are added to real part a plus c, and imaginary parts are added to imaginary part, that is I b plus id, I common, b plus d is there. Okay, then these are the properties of the addition of the complex number. Then see the scalar multiplication. See, z equals to a plus ib is the complex number. Then we multiply this complex number to any real number, that is, say k is constant or the real number, then kz equals to ka plus I into kb, right? This is the example of that. After that, the subtraction of the complex number, we can just like addition, we can subtract the two complex numbers are also. Then multiplication of the complex number, how we multiply two complex numbers here. z1 equals to a plus ib, z2 equals to c plus id. Then z1 into z2 is what? A plus ib into c plus id, that is, say a into c plus id plus ib into c plus id. Just simple multiplication is there. Now solve the bracket, that is a into c plus adi plus ibc or bci plus ibd, I into I square, and I square is equals to minus 1, right? Put the I square equals to minus 1 and simplify this. So this should be the multiplication of the two complex number. This is the properties of the complex number multiplication, right? Properties of multiplication of the complex numbers. Then power of I is what? That is minus root minus 1. Therefore I square equals to minus 1, I cube equals to minus I, right? How it is? Because I cube is I square into I, so I square equals to minus 1 into I means minus I to the power 4 is 1, right? So in this way, that is given in the form of the rotation, right? This, see here, okay, this is the example is there. So then what is there? Division of a complex number. If z1 is one of the complex number equals to a plus ib, z2 is another complex number, that is c plus id, the division is z1 upon z2, that is a plus ib upon c plus id, right? This is also simplified by the cross multiplication and taking I common. So we got these two, where first part is belongs to R, that is real, and this is again the imaginary part into I. So excluding I, the part is belongs to again real, right? These are the properties of the division. Then okay, then see some solved examples, how the example should be solved. Write 1 plus twice I into 1 plus 3i into 2 plus I to the power minus 1 in the form of a plus ib. We have to write this equation in the form of a plus ib. Say this equation is considered 1 plus 2i into 1 plus 3i divided by 2 plus i. 2 plus i का पावर माइनस 1 है, ए का पावर माइनस 1 है, तो डिनोमिनेटर में लिख लिया, पावर 1 हो गया. ओके, देन मल्टीप्लिकेशन कर दिया दोनों कॉम्प्लेक्स नंबर का. 1 into 1 1, 1 into 3i, twice I into 1 twice I, and twice I into 3i means 6i square divided by 2 plus I. Now 3i plus 2i means 5i, and I square is minus 1. 6 into minus 1 minus 6, minus 6 plus 1 minus 5, right? Then here to simplify this, to convert it into this form, ये माइनस साइन नहीं है, इक्वल टू साइन होना चाहिए, राइट? दिस इज ऑल्सो द इक्वल टू सिंबल, दिस इज ऑल्सो इक्वल टू सिंबल, है ना? इंटू 2 माइनस आई अपॉन 2 माइनस आई, 2 माइनस आई से मल्टीप्लाई डिवाइड कर दिया इसको. सो 2 माइनस आई से मल्टीप्लाई डिवाइड करने के बाद क्या मिला देख लो, माइनस 5 इंटू 2 माइनस 10, माइनस 5 इंटू माइनस आई दैट इज प्लस 5i, 5i इंटू 2 मीन्स 10i, and 5i into minus I means minus 5i square, and 2 into 2 4, a minus b a plus b से a square minus b square, 2 4 minus I square equals to minus 5. What is minus 5? How minus 5 is obtained here? See here, 5i plus 10i, that's 15i. This I square is minus 1, minus 1 into minus 5 means plus 5, plus 5 minus 10 means minus 5, okay? And 4 plus minus I square means I square means minus 1, minus minus plus 1, 4 plus 1 is 5, so minus 5 plus 15i divided by 5, and 5 से divide कर लिया तो minus 5 by 5 means minus 1, plus 15 by 5 means 3i, right? So we write this in the form of a plus ib, a plus ib के फॉर्म में हमने लिख लिया, right? Now complete this activities number 2. Complete this activity yourself and see the example number 3. If a and b are real numbers and i to the power 4 plus 3i into a plus I minus 1 of b plus 5i cube is equals to 0, find a and b. Okay, so consider this, and right side is written as 0 plus 0i, right, and left side is as it is. Then see here, I to the power 4 is 1, I to the power 4 is 1 plus 3i into a plus I minus 1 of b minus 5i cube is I is equal to 0 plus 0i. Then multiply this a by the bracket, so 1 into a plus 3ai plus I b is bi minus b minus 5i is equal to 0 plus 0i. See, this is a minus b, that is we collect the real part and imaginary part separate. So here 3i plus b, 3a plus b, I common, is equal to 0 plus 0i. Now by equality, equating both sides, we get a minus b is equals to 0 and 3a plus b minus 5 is equal to 0. Right? A minus b is 0 means a is equals to b, and 3a plus b minus 5 is equals to 0 means 3a plus 5 equals to b 5. So a is equals to b put here, thrice a plus a is equals to 5, 4a is equals to 5 means a is equal to 5 by 4, and here a is equal to b means a is equals to b is equal to 5 by 4. In this way we solve this example. Similarly, try to solve this number 4th example and 5 also. Very easy examples are there. Okay, so in this way we complete the first exercise. Now this highlighted portion in this textbook is deleted for this year, that the square root of complex number and these solved examples are deleted. Then solution of quadratic equation and the complex number system, this portion is also deleted for this year, right? This all this highlighted portion is deleted, and the exercise number 1.2 is also deleted. Okay, then this see the next topic, that's Argand diagram or the complex plane. Okay, that is a complex number z is equal to x plus I y, x y belongs to R, and I is equals to root minus 1 is expressed the point in a plane whose coordinates are order pair x y, right? John Robert Argand used one-to-one correspondence between a complex number and the points in the plane, right? So z is equal to x plus I y be a complex number, then the point p of x y represents the complex number z equal to x plus I y, that is x plus I y is equal to x y. So x represents, that is a real part of the z, it is represented on the x-axis, and x-axis is called as a real axis. Similarly, y is equal to I means imaginary z is represented on a y-axis, and y-axis is called as imaginary axis, right? In this way we consider these things, right? So diagram which represents the complex number by points in the plane with reference to real and imaginary axis is called as Argand diagram on the complex number. Okay. Then modulus of z is defined. Z is equal to a plus ib is a complex number. Then modulus of z is equals to square root of a square plus b square. Right. In this way, this is the modulus of z is defined. That's known as the modulus of complex number. Then argument of z is defined. Say OP makes an angle theta with positive direction of the x-axis. Then the theta is called as the argument or amplitude. See this one. This OP. Okay. This OP makes an angle theta with the positive direction of the x-axis. Positive direction theta angle create कर रहा है. Then that theta is known as argument or amplitude of the complex number z is equal to a plus ib, and that is denoted by argument of z, arg of z, right? So this is according to trigonometry. Sin theta equals to opposite upon hypotenuse, that is b by r, and cos theta is adjacent upon hypotenuse, that is a by r not equals to 0. So b is equal to r sin theta and a is equal to r cos theta. So tan theta equals to b by a. This is very easy, that is part of the trigonometry. then argument of z in the different quadrant. This chart is learned by you. Okay, then see how examples are solved here. If z is equals to 1 plus 3i, find the modulus and amplitude of z, right? So z is equal to 1 plus 3i, hence equating this with the standard equation of the z equals to, that is a plus ib. So we get a is equal to 1, b is equals to 3. A and b both are greater than 0. So modulus of z equals to square root of a square plus b square. So 1 square plus 3 square, that is 3 square is 9 plus 1 square is 1. 9 plus 1 is 10. So root 10. Okay, and amplitude of z is tan inverse b by a. By using that formula, so that is tan inverse 3 by m is tan inverse 3. This is the amplitude of z, right? So in this way this example is solved. Then this second is also very easy example. Try to understand yourself. Then the properties of the modulus of the complex number. See, these are some properties. This is not important part, but one time learn these properties. Then the polar form of the complex number is that. This is also is not important part. Okay, right? Then see this exponential form of the complex number. So it is known as, and can be proved using special series, that e to the power I theta equal to cos theta plus I sin theta, z equals to a plus ib is equals to r of cos theta plus I sin theta is equal to r of e to the power I theta. So r is equals to mod of z and theta is equal to argument of z is called as exponential form of the complex number, right? So this is also not important part, and these examples are not also not important according to your examination purpose, right? So leave this part also for yourself. Important part नहीं है ये, छोड़ दीजिए, ठीक है? Then De Morgan's theorem. This is also deleted. This highlighted portion deleted for this year. Then cube root of unity. This part is important for this chapter. Cube root of unity part important hai. So we can take this part in the next lecture and see some examples on this in the next lecture, right? Cube root of unity and the properties of this cube root of unity. We can take this to the next class, right? Okay.